for x and z scores given areas or probabilities. Let's look at some examples on finding z scores. Example 1. We want to find z if the area to the left of z is 0.8921. It's always advisable to draw the curve in order to visualize the area and the position of z score. I have placed z on the right of the center here because 0.8921 is greater than 0.5, and that tells us that the z score will be positive. So we go to the positive z score section of the table and look for the area closest to 0.8921. Note that the z scores are printed in red and the areas in black. The closest area to 0.8921 we find here is 0.8925, corresponding to a z score of 1.24. In the second example, we want to find z such that 71.9% of the area is to the right of z. 0.719 is greater than 0.5 here, and it is to the right of z, so z has to be on the negative side of the center. So we go to the negative section of the table. Since the areas in the tables are less than areas, we need to find a less than area corresponding to z here. That is 1 minus 0.7190, which gives 0.2810. Searching the area section, we find 0.2810 exactly here, corresponding to a z score of negative 0.58. In the third example, we want to find the z score corresponding to the 10th percentile. Since percentile means percent below, we have 0.10 of the area below z, and so it will be on the negative side. The closest area to 0.10 we can find on the table is 0.1003, and that corresponds to a z score of negative 1.28. So the z score corresponding to the 10th percentile is negative 1.28. Now recall the standard normal score transformation formula. To recover x, we can simply make x the subject of the formula by cross-multiplying and bringing sigma up, and then moving the mean to the left, and finally exchanging both sides. Let's see the application in the following example. Suppose we have a normal distribution with a mean of 20 and a standard deviation of 3. We want to find the score that represents the 85th percentile. Since percentile means percent below, we first draw the standard normal curve and place 0.85 to the left of z here. Now, doing reverse lookup in the positive section of the z tables, we see that the closest to 0.85 is 0.8508, and that corresponds to a z score of 1.04. We can then substitute the values into the z formula and solve for x, or we can directly apply the x formula we obtained earlier, and substituting the values gives 23.12. So the 85th percentile is 23.12. Next example. In this one, we want to find a score such that only 8% of the values are above that score. That is, we have 0.08 in the right tail here. Since the areas in our tables are less than areas, we do 1 minus 0.08 to obtain a less than area of 0.92. We then search for the closest to 0.92 in the table, and the closest we find here is 0.9207, which corresponds to a z score of 1.41. Substituting again in the x formula, we have x equals 24.23. That is, only 8% of the scores are above 24.23. Let's look at one more example. Here we want to find two values, a lower limit and an upper limit, that will be boundaries for the middle 75% of the scores. With 0.75 in the middle, we have 0.25 divided equally into the tails, that is 0.125 in each tail. For the lower limit, we go to the negative section of the tables and search for the closest to 0.125. The closest we find here is 0.1251, which corresponds to a z score of negative 1.15. For the upper limit, the area below is 0.75 plus 0.125, which gives 0.875. Looking that up in the table, the closest is 0.8749, corresponding to a z score of 1.15. That should be expected because the normal curve is symmetric. That is, we don't even need to look up the positive z score. Symmetry should tell us that it will be positive 1.15. Let's now calculate the actual scores. For the lower limit, substituting negative 1.15 gives 16.55, And for the upper limit with positive 1.15, we have 23.45. In summary, to recover a score for a normal distribution, construct the normal curve identifying the area of the required probability, then search for the closest less than area to it in the Z tables. Once you find the closest area, locate its corresponding Z score, and if necessary, substitute it into the X formula to obtain the required X value. And that's it for this video. Thanks for watching.